Good morning to all, and this subject which I am going to handle is software process and project management. From the name itself we can make it out, software process and project management. See here in this course you will learn how to manage the project first, and inside the project what are the process, how the process can be managed. So let me start with the software development life cycle, because this is what are the software development life cycle, what are the life cycle availables, how it can be used to manage the process as well as project. See this you might have studied in software engineering. Software engineering, all the detailed models you have studied, and every model is designed for certain purpose, and it can be customized according to the project nature. So let us just brush up the overview of software development life cycle model. In short we can call it as SDLC. SDLC. What is software development life cycle? It can be sometimes in some book it is referred as a software development life cycle. In some book it is referred as a system development life cycle, where software is a subset of system, so it can be pronounced in both the way. What is SDLC? It stands for software development life cycle. We can say it is a standard model used for developing a software. So there should be a approach, there should be a procedure to do any task. If you want to carry out some task, there should be a methodology, there should be steps. We can say in small level algorithm, in higher level we can say it's a model or it's a framework. Why we have to follow certain framework? To ensure the quality of the software. It is necessary to ensure the quality of software. So we need to work under certain domain or framework. And you can define this SDLC. It mainly focuses on what are the logical steps taken to develop a software product. So SDLC is a software development lifecycle model, or you can say standard model used to develop a software. It can focuses on logical steps to be taken to develop a software, or it is at the same time it ensures the quality of the software. Let me just explain one scenario. Suppose I own a company. My company is totally, it's not an IT company, some company like painting, automation, or we have some manufacturing company. In that company, if I want to just computerized, I want to develop a software, automate my entire office processing or entire functionality of the company, then I should approach any one of the IT company. Suppose if I want anything like, if I want a swing which should have the both hands and the one of the branch of the tree. This way how the customer explain it. See, before that, can you edit this? Suppose you assume the scenario that without software development life cycle, what happens? See, if you don't have framework, or if you don't have standard model, the way of interpretation, the way of understanding is varies from one person to another person. That leads to misunderstanding of the system, leads to misconceptual, and ultimately the failure will happen. So if you could see the example, you'll realize the things. Let us assume that the customer wants to develop a model for this. So this is way how the customer explain it. How the project leader understood it, because it directly goes to the project leader. The same concept is interpreted by or understood by the project leader like this. How the project leader understood. How the system analyst designed it. So because the input is taken from, first project leader takes input from the customer, then system analyst takes input from the project leader. So how the system analyst designed the model. Now how the programmer wrote the code. This what happens in real time application. And how the business consultant described it. Business consultant is the person who marketing the software. How he described to the another client or another person. How the business consultant described it. And how the project was documentation. That means it is zero documents, nil documents. You can't infer anything from this. Then what operations are installed. See what customer explained, what operations are installed, how the customer was billed, and how it was supported, what the customer really needed. See, even there is a conflict between customer explanation and customer understanding. Even customer himself, he doesn't understand certain things. In due course, whatever he understood, he explained to the project leader. Project leader interpret on his own way, and system analyst understand on his way. So this, if it is not there in the framework, it is never end kind of thing. The boundary goes beyond the limit. So to avoid this, all these persons should come under the framework. That framework we can call it as SDLC. So we can say software development SDLC. It's a framework that describes the activities performed at each stage of the software development life cycle. There may be 10 stages, or there may be 7 stages, depends upon the model, life cycle model. So this SDLC, what SDLC deals, it's the only operation is same, but mode of operation is different. What are the, in all the phases, if you see, first requirements, analysis, design, implementation, testing, validation, and deployment. All this is common, but the every model it has its own pros and cons. It deals the things in different manner, but this is the ultimate process how it should be done. So the framework will be generic framework. It is common. It describes the activities performed. What are the activities to be performed? If we say first stage, these activities should be covered. In the second stage, what are the list of the activities to be covered? So these things is described by software development lifecycle model. So in general, it has 5 phases. This is common to all the lifecycle model. It has planning phase, analysis, design, implementation, and support. Implementation and support. Planning phase, see, first it, as we discussed before, it takes inputs from the customer, and so in general there are 5 phases in the system or software development life cycle. First one is planning, second one is analysis, third one is design, fourth one is implementation, and fifth one is support. For example, in planning phase, first we take input from the customer, what are their requirement, and then analysis their requirements. Based on the requirements, what are the requirements needed in the project, and based on the project request, we need to prioritize which request should be sanctioned first, which one be sanctioned second, and allocate the resources for each project request. It can be both hardware, software, as well as manpower, and finally identify the project development team. This is happening in the first phase. It is irrespective of any model, irrespective of any kind of project, these things will happen in the first requirement analysis and planning, allocate the resources. Whereas in analysis phases, it generally how much actually what are the requests can be compatible with the existing system, and the preliminary investigation will be done in the analysis phase. Then what are the existing system, what are the user requirements, how it can be, what are the constraints, how it can be recommended, what are the recommended solutions. So all these things will be decided in the analysis phase. After deciding, after completing the system study or analysis phase is over, then next one is design. Design is nothing but what are the hardware, software required to be designed, what are the model, database design, it can be database, program, algorithm, data structure design, all these things happen here in this. So the complete details of the design will be designed in the design phase. After designing, what are the models, what are the algorithm we have designed, it can be converted into the programs, and it will be implemented. Implementation and in the training the users, and implementation deployment at the client level is a part of this phase. Finally, fifth phase, support, conduct post implementation. After deploying the software, maintenance should be required. For any system, maintenance should be required if there is any changes, because our system should be, what are the software you are developing, it should be adaptable to changes. So if required configuration changes, if required any requirement changes, that can be also be accommodated through support. These are the 5 phases, is common to all the models. Let us see how this life cycle model differs from one model to another model. There are almost 7 common models are available. See, one is actually the main purpose is, as I said before, it is a generic framework. It can be customized for any kind of project, and with certain parameters should include. When you are customizing, certain parameters cannot be compromised here. That is one of the parameters is size, number of persons and how long it will take to complete. What is the team size and how long it will take to complete the project. Second one is budget. Third one is duration, time, budget as well as size. These 3 are the very important, and these are the major challenges for any project. If you plan proper staffing, proper schedule and proper finance, then that project will be more successful. So when you say project plan, is nothing but a life cycle model plus project parameters. Life cycle model can be any type of model. Based on the project nature, you can select life cycle model, and project parameter is number of people, team size, time as well as budget. Team size, time means duration. Team size, duration and budget plus life cycle model is equivalent to project plan. In SDLC, it follows 2 approaches. One is predictive approach, second one is adaptive approach. Predictive approach, certain project can be planned out earlier and you can implement as per plan. There won't be much change. That is called predictive approach. Whereas in adaptive approach, it is more flexible. It can be like the project cannot be planned out earlier, but it can be parallelly planned, and parallelly it is the adaptability is more in this kind of adaptive approach. It can change then and there. And every phase, if you want, there is change in requirements that can be adopted here and the next consequent phases. So all the project uses some variation of SDLC. See, it's necessary this project should use this type and this should not use, based on the nature of the input, nature of the project, nature of the input, market size of the project. You can select any type of the SDLC model. There are 7 models are available. One is waterfall model, second one is V model, and third one is incremental model, RAD model, agile model, iterative model and spiral model. Apart from that, CMM is there, that we will see later. By changing the life cycle, how one life cycle model is differ from other life cycle model based on the speed, how fast it is capable of developing the software or completing the project. So development speed, product quality is very important. So Tara Mantra for any software, quality of the software, and visibility of the project, how the project will be visibility, how the transparency there in the development cycle, and what are the administrative overhead, and what are the risk exposure, customer relationship, certain customer relationship, etc. These are the 6 parameters we need to consider before choosing the life cycle model: development speed, product quality, project visibility, administrative overhead, risk exposure, and finally customer relationship, etc., etc. When you choose any for particular project, if you are choosing a particular model, whether your requirements are stable, it will not change, then you can go for life cycle model. If the requirements keep on changing, then you can go for prototype model. Based on the software, whether it is software project or hardware project or embedded system project, we need to select certain life cycle. So the first life cycle model is waterfall model. This is one of the traditional model. This is very old model, but it is standard model. When you want to ensure the quality of the software, we have to go for waterfall model. It is invented in the year 1970 by Royce. See, this waterfall model consists of again 6 phases. First one is requirements, second one is design, third one is implementation, fourth one is test, installation, maintenance. Requirement phase, actually it defines what are the information to be needed, what are the functions should be there, what are the interfaces should be defined, interfaces and how it should perform. All these things are defined in the first phase itself. And the design phase, what are the data structure, what are the software architecture, what are the hardware architecture, and how the interface can be represented, how the algorithmic, what kind of approach should be used for writing an algorithm. All these things are decided in the second phase. Implementation, after deciding algorithm, data structure, only thing is you need to convert into programming language or what are coding, and implementation will happen in the implementation phase. Finally, testing. Test is after, you can user documentation, testing, after testing, installation and maintenance. These are the approach. Actually, user requirements can be converted into software requirements. From the software requirements, you can design the architecture. After designing the architecture, the detailed design will be converted into coding. After coding, it can be implemented and tested. Finally, delivery of the software. This is the timeline of waterfall lifecycle model. This we can say if there is any change in the suppose delivery stage, then it should go to the testing. From the testing, it should go to the next. It should go up. First, it will travel top to bottom, then bottom to top. This approach is called swimming upstream approach. And the one more beautiful thing is here every phase there is output. Every phase you can get an output. Deliverables are there in, at each and every phase. User requirement phase output is user requirement document, and that is URD. Software requirement phase the output is SRS, SRD. Architecture design document will be there, and detailed design and coding will be there. Like this, every stage there is a deliverable in the waterfall life cycle model. Apart from what are the strength of this waterfall life cycle model, it's easy to understand, easy to use. Even non-computer person can easily understand the thing, and they can implement with the help of this life cycle model. It provides structure to inexperienced. There is no prior experience required to handle this model or to operate this model. Milestones are well understood because at every phase there is a output. So at the end of the third phase you will get a design document. If you don't get a design document, then you can just review the project. All these milestones can be understood, or milestones can be fixed, well understood. Sets the requirement stability. Here the requirements are stable. When your requirements are stable, then only you will be able to concentrate on quality of the software. Good for management control. Here requirement stable, everything stable means good control will be there, like planning, staffing, tracking, all these things. Works well when the quality is more important. It focuses only on the quality and the cost more than the cost and the schedule. So when you go for large scale project, this may take lot of this may feel a lot of expensive model. So this will work on the small project with the stable requirements. Simple and easy to understand and use advantages. Easy to manage due to the rigidity of the model. The model is very rigid because at each phase there are deliverables, so no need to bother about the things. Phases are completed one by one. After completing requirement phase, it will come to design. After design, it will come to the implementation and so on. It works well for small project where requirements are clearly understood. And what are the deficiency of waterfall model? It idealist does not match the reality well, because we follow certain assumptions. We need to assume certain things. It's a totally traditional model. It's not a updated model, so it does not match with the reality. Does not reflect the iterative nature of the exploratory development. When you do some task repeatedly, this will not suit it, and it is difficult to, or it is unrealistic to expect the customer to provide accurate requirements, because during interaction the customer inputs can be taken in different form, by paper pencil or by interaction, by interview. Mindset of the people will change from one day to another day, so the same way the requirements may change, plus or minus would be there. So when you apply this model, if the requirements keep on changing, then it will not give the quality of the software. It will not yield the much quality of the software. And one more problem is here is it is delivered late in project discovery, delays discovery of series. Suppose the project is delivered, if it is delivered within 3 years or 36 months, it should be delivered. If it is delays, but the cost will become multiple. So a series of errors will occur. Difficult to integrate risk. There is no chance of covering up the risk. Here in this model, we are not talking about any risk exposure. So there is no provision to integrate the risk management. Difficult and expensive to make the changes. If you want to change any small change at any stage, it should travel swimming upstream method. So it takes lot of time. And significant administrative overhead, costly for small projects, small teams and project. It is costly for small teams and project. It is administrative overhead is there because of its nature, because it doesn't cover exposure. It just ensures the quality. Totally traditional model, there is no flexibility. So administrative overhead is more. So these are the deficiency of the project. This can be applied for the project which has a stable requirements. When to use waterfall model? Requirements are very well known. Product definition is stable. Technology is understood. New version of existing product. Porting an existing product to new platform. So the waterfall model can be suitable. As I said before, this is suitable for well-known. If any project has just well-known requirements or stable requirements, we can go for this. And if you want to extend any product, suppose if you want to expand any product, then already the model it might have followed. From that, you can, if you want to extend, you can use this from the existing product to the new platform. If you want to convert any product, suppose it is developed in Windows, if you want to convert in Linux, if you want to follow the traditional life cycle, you can go for this kind of life cycle. And here the technology should be understood, product definition should be stable, and requirements should be well known. Then only this model is suitable. So next model is, can we next model is V-shaped SDLC model. This is variant of waterfall model, but it emphasizes verification and validation of the product. Here the testing of the product is planned in parallel with the corresponding phases of the development. If you see the phases are V-shaped. First phase is project requirements and planning. Second phase is product requirements and specification analysis. And third one is architecture high level design, detailed design, coding, unit testing, integration testing, system acceptance testing, and product operation and maintenance. If you could see the first phase, project requirements and planning, here as usual it just decide what are the project requests, prioritize the request, and based on the request it allocate the resources for based on the project request. And second phase, product requirements and specification analysis. What are the functions of softwares, how these functions should be defined. Here software functions or software architecture can be defined here in the specification analysis. And then architecture high level design. In this level, what are the functions we have designed in the level, second level, that can be converted into the design. The functions of software functions are converted into the design. And the detailed design, what are the data structures, what are the algorithms, all these things are defined in the detailed design. After that, it is converted with the help of any programming language, that is called coding. And parallelly unit testing, every time after converting, it can be tested, each the software model can be tested unit wise. See, in V-shaped model there are 9 phases. In first phase is it allocate the resources. Second phase, this provide the complete specification of the software system. And third, how the software functions fulfill the design. And fourth phase, how for this design, what are the architectural component and algorithms, how the algorithm should be developed for this algorithm, for this design. And finally, transform the algorithm into coding and check the model whether the model can be acting as we expected. And finally, how these models are interconnected. Interfacing can be checked in the integration and testing. The interfacing, how it is compatible each other. And finally, the whole system test, system acceptance testing. Check the entire software system in its environment. Provide for enhancement and corrections. It happens in the final phases. So there are here you just see if you see look at the diagram, and every phase gets input in the last phase, like project requirements and planning. The main purpose of this phase is to allocate the resources after identifying the project request. But in case actually if there is enhancement or anything is required, that immediately intimated to the first phase, so that it can refine their requirements. At the same time, product requirements and specification analysis, what happens, it just define how the software functions should be performed. And suppose the system acceptance of the feedback, like a system is not accepting, or we have defined system in one way and the output shows in different way, that can be sorted out by interacting these two phases. So that's why it is called V-shaped SDLC model. Here it's not the requirements is not to be, it's not necessary to be stable. Let us see how what are the sense of V-shaped model. Here it emphasizes on verification and validation of the product in early stage of the product development, because in other model all the verification is done either at the fake end or it can be after deployment. Before deployment we check, but the detailed verification or validation will be checked in the client site itself. But here this can be done parallelly in the early stage of product development, and each deliverable must be testable, because there are 9 phases of the in this model. There are 9 phases, and each output of the phases can be checked then and there with the concerned phase. And project management can track the progress by milestone. Here also we can fix up the milestone, and tracking of the project is very easy and easy to use. Again, it has its own weakness. It does not easily handle the concurrent, because we are saying that V-shaped model, it's directly first project phase is talking to the product phase, and next system functions is talking to the system acceptance testing. So it's all interacting parallelly. It's not easy to handle certain things parallelly. It's difficult. Overhead is there. Again, depends upon the nature of the project. This model should be adopted. Does not handle iteration or phases. Here there is no one after another. It's everything parallel. So it is difficult to handle the iteration here. Does not easily handle the dynamic changes in the requirements, and it can accept changes in certain extent, but dynamic changes cannot be done over here, and does not contain risk exposure. There is no risk analysis activities. There is no risk exposure in this model. When to use this V-shaped model? Excellent choice for system requiring high reliability. Suppose you want high reliability, accuracy is more, and software system should be developed in a certain particular domain, then you can go for this V-shaped model, because it just refinement, everything happens inside particular domain. In that case, we can go for V-shaped model. All the requirements are known upfront. So before starting up the project, all the requirements should be clearly defined, and it should be known upfront. And solution and technology are known. We should know what kind of technology we are going to follow, and how we are going to yield the solutions. If we know everything already, like before starting the project, and this model is best model, because this model mainly focuses on verification and validation. Once you develop any project with the help of this model, it is the rigid, it is a robust kind of thing. It will work year to year. And next model is prototype model. Now you know what is prototype. It's a kind of prototype means it's based on the requirement. Before developing the actual product, we can develop a model of that product, that is called prototype. For that we have a separate model called evolutionary prototyping model. Here what this user does, based on the requirements collected from the customer, the team develops the prototype, build the prototype, and prototype is evaluated by the end user. Immediately after developing product, it is given to the customer to test, and what are the corrections or what are the feedback. Based on the feedback, the model, again prototype has been changed. So developers further refine the prototype, and when the user is satisfied with the prototype, there ends the software development. So the prototype model, after getting the requirements, it immediately the prototype will be built. It will be given to the users to check the function of the software. If everything okay, this loop iterates till the user is satisfied with the prototype. This is requirements capturing requirements from the customer. And quick design, because prototype you can do the complete design. Suppose if you want to release, there is a model I-20 something Expedia or model is there. If you want to increase, if you want to just improve some of the design, and if you want to go to the next model, before go to the changing into the real time, then first the prototype will be changed, how the door will be, how the dashboard will be, all these things, and the new look and feel will be presented in the form of prototype. If a customer is satisfied with the customer, or whoever it is, client is satisfied with them, then it can be implemented. The same thing here, requirement. After capturing the requirements, quick design will be done and build the prototype. Customer can evaluate. Here customer directly talks to the system. That's a scope for interacting customer directly at each and every phase. Customer evaluation of the prototype. If it is this is like a iteration. This loop will continue till the customer is satisfied with the prototype. Then after that, if once it's satisfied, the final product will engineer the final product. This is called rapid prototype workflow. What are the steps? in this model. First, the preliminary project plan is developed. Plan is developed as usual. A partial high-level paper model, because here there is no necessity of buying components and designing the architecture or designing the model. Only paper model is designed first, and then the paper model should reflect the source of the requirements, source of the partial requirement specification. And prototype, how while building the prototype, what are the things to be considered. The prototype means it should include what database we are going to use, what kind of interface, and what are the algorithmic functions. This prototype should cover all these three domains. So the designer demonstrate after building the prototype, it can be given to the customer. The user evaluates the problem and suggestions will be taken from the user for the further improvements. This loop will continue until the user is satisfied. So what are the strength of this model is actually customer can see the requirements as they are being gathered. See, because we are taking the requirements from the customer, but you can take it from the different customer means not only one person, maybe more than one person can give the input for the particular project. So when you develop the prototype model, all the customers can able to see the requirements what are they are being gathered, and learn from the customers. Developers can learn from the customer, because developers actually they are directly interacting with the customer. Based on the customer input, they are changing the model, changing the design, by which they are gaining the knowledge from the customer, and more accurate end product. More if you do, lot of refinements are going on. If we keep on changing the model and based on the customer requirement, and final product will be the pakka. It will be more accurate, and even unexpected requirements also can be accommodated. It is and this model allows flexible and design and development, and it provides steady visible signs of the progress is produced. Interaction with the prototype stimulates awareness of additional need functionality. Suppose if you are since from the beginning itself you are interacting with the customer, based on the customer you are developing a prototype. This is iterative nature, and what are the at one point of time, if the prototype is satisfied by all the users, means you will get a final product. That final product is capable of adapting, or it provides scope for adding the additional functions. In case in future, if you want to expand those prototype or those model into if you want to expand, or if you want to add additional functions, that is also possible with the prototyping model. Again, it has its own weakness. What are the weaknesses? Tendency to abandon. See, there's no, in this model, prototype model, there's no structured development. There's no structure, there's no streamline. Anybody wants to do anything, and directly they can impose their requirement, they can implement into the model. And there is here in other phase, requirement planning, like analysis, design, implementation, it goes in structured way. Here there's no structured way. Make something, just give it to the customer, and if they say, and add the feedback, and change thing and modify thing, again it keeps like this. It's a kind of quick and dirty methods. So it's not and all the companies or all the project cannot adapt this prototype model. Overall maintainability may be overlooked. Again, when we do like this, actually overall maintainability, because we are doing even if we charge for $3, we are working for $5, because for every requirements, if it is goes to the customer and modify, going to the customer and modify, means you are doing more service than. So overall maintainability may be overlooked. The customer may want the prototype delivered. See, once if you develop the prototype, and the customer maybe before deployment of the software, the customer may require the prototype to be delivered, which is not possible according to the norms, and process may continue forever. It's kind of gripping things. The process will be never ending if in changes, then because this model has a flexibility, changing and again evaluating. Because of this nature, this model can be the process is continue forever. When to use this type of prototyping model? Requirements are unstable or have to be clarified. Again, requirements are stable means you can go for V-shape and waterfall. If it is unstable means we can go for prototype model, and it develops user. If you want to develop a user interface, if you want to have a strong interface between the user and model, then you can go for this prototype model. And short-lived demonstration, because for every we are doing some changes and we are demonstrating to the customers, and customer giving some input, based on the input again changing, and this keeps continuing. So the short-lived demonstration, when your final product demonstration, maybe customer may not be interested to see, because they might be knowing what all the things happen in between. They might not be interested to see that. With the analysis and design portion of the object oriented, mainly this can be, since as I said before, the functionality can be extended, so we can use this type of model in object oriented analysis development. Okay, next model is rapid application model. Here everything are developed in terms of phases. There are 4 phases. One is requirement planning phase, second one is user description phase, and third one is construction phase, and final one is cutover phase. What is happening in each phase? In the requirement planning phase, the objective of this requirements planning is collecting the requirement and analysis and pre-writing the requirements. Based on that, we can plan further. So for that, what it does, it works up utilizing the structured discussion of the business problem. This is mode of collecting the information is different, interacting. So they are in this phase, it's a kind of a workshop is being structured to discuss the business problem. Next one is user description phase. All automated. After that, after discussing and to capture those information, some tools can be used. Automated tools capture the information from the user. Then only for construction phase. Construction phase, all tools are used in here. Productivity tools, such as code generator, screen generator, etc. Inside a time box, to until done. Time box means actually the whole entire project time is divided into 3-4 weeks of duration, and each one is called time box. Finally, cutover phase, installation of the system, user acceptance testing, and user training. If you see this model here, they are giving more importance to the first 2 levels, actually getting customer information, understanding the customer requirements, whether it is function, non-function and requirements, it should be understood clearly. So for that, they are spending in the 2 phases, requirements planning phases and user description phases. Requirements planning phases, simply they just discuss the problem, what are the problems are happening in the business, and to capture the problem, some tools are there to capture the information that is happening in the user description phase. After that, construction phase is all design, analysis, everything happens in the construction phase. For that, it has tools and techniques such as code generator, screen generator, etc. Finally, installation of the system, validation and verification. This is like team 1, it does business modeling, data modeling, process modeling, application generation and testing turnover. This is if it takes 60 to 90 days. Parallelly, another can start. This is the way actually here in rapid model: business modeling, data modeling, process modeling, application generation, testing and turnover. What is strength of rapid application development? It reduced cycle time, improved productivity. With the fewer people means lower cost. Here, time, cost and all very less, more productivity. Customer involved throughout the complete cycle minimize the risk of not achieving the customer satisfaction and business needs. Customer involved throughout the complete cycle minimize the risk of not achieving the customer satisfaction. There is no special phase for us to satisfy the customer, because customer involved in each and every phase over here. And focus moves from documentation to code. Here the documentation is given less weightage because everything can be modeled. What you see is what you get. Uses modeling concept to capture the information about business data and process. So if you see the strength means it takes less time, more productivity, so less cost, and customer, there is no need of getting a special scope for to satisfy the customer, because customer involved each and every stage, and there is no separate documentation because it follows what you see, what you get. And it uses modeling concept to capture the information, model the information, and as well as process the information. What are the weakness then? Because rapid application development, it should give the quick responses to the customers, because everything is modeled here, so it must give quick response to the user. Risk of never achieving closure. Here actually, if we start developing, we have to have a any project with the RAD, there won't be any closing point. It keeps on iterating or repeating again and again. Hard to use with the legacy system because everything is modeled, there's no documentation. What you see is what you get. So it's very difficult to accommodate with the copyright, all these things. Developers and customers must be committed to rapid fire activities in the abbreviated time frame, because the developers should move with the customer speed and vice versa. The frequency should match, because this rapid application development, it requires quick response from the user as well, and vice versa. So that they are committed to be rapid fire activities in a stipulated time frame. When to use RAD? User involved throughout the life cycle. If a customer want to sit with the entire project life cycle SDLC model, then you can go for RAD model. Project can be time boxed. Time box means it's a kind of machine. Each time box consists of 4 to 6 weeks, and milestones or deliverables is fixed at the end of the time box. Functionality delivered in increments. So all the functions can be implemented, not implemented at once. First level function, and it can be incremented or it can be delivered in increments. Next model is incremental SDLC model. From the name itself we can identify that is incremental. The entire function of the system cannot be implemented at once. It can be implemented, the functions can be added in the incremental manner. So it constructs a partial implementation of the total system, then slowly add the increased functionality, and it prioritizes the requirements of the system. Based on the requirement of systems, it implements in them group. First level, this function will be implemented, second function 2, function 3, like this it increments the, or it adds a function step by step. So each subsequent release of this system adds the function of the previous release plus what are the new function has been implemented. All these things will be shown in the every release if it is developed with this incremental SDLC model. Here also same thing actually, system feasibility, software plans and requirements, product design, after that detailed design, code, integration, implementation, operation and maintenance. These three are the common. Feasibility study, software plans and requirements, and product. Till that actually it is common. All these things will be decided at a stage for a complete function of the software. After that actually these things will be repeated. Detailed design, code, integration, implementation, because the entire function is divided into small functions, and first it will implement the first function, then release, then add additional function. Like this it keeps continuing. This is like build 1, design and development, testing, implementation. Build 2, design and development, because still requirements is common. Requirements, planning, analysis, everything is common. After that one design part is common, it will design each function is separately. Then finally it is in the final product you will get the all the models with the additional functions. What are the strengths of incremental model? It develop a high risk major functions first. Suppose in a software development, first it will identify what are the project immediate requirement, what are the major functions that can be developed first, and additional functions can be added stage by stage. Each release deliverables are as an operational product. See, when you complete one function, it can be delivered as an operational product. It cannot be delivered as a intermediate product, or it cannot be delivered as a software. Customer can respond to each. This looks like prototype. In the prototype or model also, we do something and give it to the customer. Customer satisfies, then we'll stop it. If customer doesn't satisfy, we'll take input and then again we'll refine. That is prototype model. Here what we did, we see function 1 will release. If there is any problem, then that will also be considered. Along with that, additional functions will be implemented, and then the next product will be released. It uses the divide and conquer technique. The entire task is divided into and then merge the output. Lowest initial delivery cost. Since initial delivery cost is only one small function is delivered, then delivery cost will be less. Initial product delivery is fast. First beginning actually you can customer will keep quiet, because they will get the input, or they will keep on get the output from the company. Like initial product delivery is faster. Every 3 months or every 2 months you can new product will be given to them, and customers get important functionality early. Customer, if they based on the after prioritizing the request, important functions will be delivered fast, and risk of changing the requirement is reduced because it's each one is dealt by separate function. The changing requirements will be reduced because in suppose if additional function will be there, then requirements for new requirements, new additional functions will be created. What are the weakness? Requirements good planning and design. This is very important for incremental. If you are when you are using divide and conquer, first you should know how many tasks will be there, how many functions are there, where how it can be divided, which functions should be given first priority, from where to start. All these things will be more important in this model. So requires good planning and design. Requires early definition of complete fully function system. So as I said, planning and phasement, it includes complete function of the system should be known earlier, and requirements also here upfront. Well defined model interfaces are again you are using divide and conquer method. The interface is very important. It should interact with each other. The model should be compatible. There should be hiccups between the modules, and total cost of the system is not lower. Even when you do like this, the total cost of system will not be reduced, but only thing is actually there is vibrant in this model. Customer we make the customers give busy by just checking the each functions. If there is any requirement that can be updated then and there. When to use this increment model? Most of the requirements are upfront but are expected to evolve over time. Maybe requirements should be known. It allows little flexibility. If there is change in requirement, that also can be adaptable because of the additional function nature. They need to get basic functionality to the market early. So for anything, what are the important functions? That function should be prioritized first for any software. That should be delivered first. On projects which have the lengthy development schedules, on project with the new technology. See, any project which has a lengthy development schedules, like it has 4 years, 5 year project. If any person sitting quietly for 5 years, after 5 years, if you release a project, then it's very difficult to realize the output of those projects. So in that case, if we go for incremental, every year periodically something will come, so that the people get used, our customer get used with that product, and with the technology as well as new technology with the technology. Then next model is iterative model. Iterative model is like the complete, instead of prototype, we will develop the prototype, then give it to the customer. Customer gives a feedback and it comes. This is only one iteration. Here every phase iteration is there. First it collect the requirements and give it to the whether requirements are correct. Interact with the customers, get their feedback, then change the requirements. After that analysis, after that design, coding. For every phase we are taking the customer feedback. That's why it is called iterative model. Look at this actually here, where is from where it starts from analysis. Its analysis includes the requirements also. Analysis, design, implementation, integration and deployment. So before getting into the next phase, it takes input from the customer. Once the customer feedback is implemented, then the end last product will be the final product, will be the complete product. Directly it can be deployed. Advantages of this model is actually we are building involving the product step by step, hence we can track the defects at the early stages. So every time we are taking the feedback, if there is any flaw, if there is any defect in the system, that can be corrected in the early stages with the interaction with the customer. We can through this model we can get reliable and user feedback. When user feedback, and when presenting sketches and blueprints of the product to the users for their feedback, we are effectively asking them to imagine. Here there is no imagination. The main thing is there is no imagination. Immediately we are giving their product and they are testing, they are seeing the product and getting we are getting feedback from the customer, implementing and then giving back to them. Everything is in the black and white. There is no need of imagining things. What are the disadvantages? Each phase of iteration is rigid with the overlap. Here there is no flexibility. There is no flex. Suppose actually after analysis you are getting feedback and you are doing again analysis. After that you came to the third stage. Suppose if you want to do something configuration management, if you want to do something in the requirement phase and analysis phase, that is not possible. Here each phase is rigid because it is one way travel. It is taking input from the customer feedback, and system overhead is administrative overhead is there because of the architecture and design issues, and all the requirements are gathered in the entire life cycle. So obviously administration overhead is there. And next model is spiral model. What is spiral model? It actually, so far the model have been discussed, risk analysis, there is no less focus for the risk, but spiral model concentrate on risk analysis or risk exposure. It adds risk analysis and prototyping, adds risk analysis and RAD prototyping to waterfall model. This is nice, a combination of RAD waterfall model, as well as along with that model it adds the risk analysis procedure or risk management plan. Each cycle involves the same sequence of steps as the waterfall process model. Here also you can stop requirements, design, implement, and then testing completed. Here if you see this area, it allows a RAD model. This area it looks like a water flow model, and again it includes all the four quadrants. Actually it includes the risk also. In first quadrant it determines the objectives, alternative, constraints, objectives, what are the alternative plan and the constraints. In second, what are the alternatives, or it evaluate alternatives, identify the resources and resolve the risk. Here risk is included. And third level is develop a next level product, and fourth will plan the next phases. So let us see one by one. In the first quadrant, determine objectives, alternative and constraints. Objective, what is objective? What are the functionality of the system? What are the performance of the system? What is hardware software interface? What are the critical success factors, etc. These are the concerns, objectives. What are the alternatives? What are the alternatives for developing this product? How to build, how to reuse, how to buy or subcontract, etc. based on the requirements. And what are the constraints? Constraints, obviously three constraints: cost, schedule, generally cost, schedule, interface, etc. In general, the project parameter, there are three constraints: cost, schedule and performance. Here one more thing we need to take, interface. And evaluate alternatives, identify and resolve the risk. Here the risk is included in this model. Study the alternative related to the objective and constraints. We can define one model with the objective which includes all the objectives as well as constraints. What are the alternatives and how these alternatives can be evaluated. Identify the risk. Suppose if it is not finished within 3 years, or if it is not finished within this budget, then what are the risk? How it can be managed. Maybe risk if you have lack of experience, because of lack of experience, because of new technology, because of tight schedule or poor process, etc. You may face to risk may occur. So how will you risk can be evaluated, or how will we risk will be mitigated? That is called resolved risk. Evaluated if money could be the loss by continuing the system development. Suppose if this risk happen, only we lose money, means then we can continue, or depends upon the nature of the project, the risk mitigation plan should be developed. And next level product, develop the next level product. So what, after identifying the alternative, evaluating alternative constraints and objectives, what are the typical activities to be performed in the next level is create a design, review the design, and then code, develop a code, inspect the code, test the product, implement and test the product. Design, coding and testing. And next phase is actually plan. Next phase after coding and testing means here itself we will get the product. Next is actually develop the project plan, develop a configuration management plan, test plan and installation plan. Develop the project plan for next level. Configuration management means if change requirements, how it can be adopted. Change requirements, if there is any change in the requirements, where and all, what are the phase will be affected, how it can be managed. That is called configuration management plan. After that, a test plan. We need to develop a test plan, how it can be tested, whether unit test or black box test, white box test, or how the testing can be, acceptance testing can be done. For that we need to develop a test plan. Finally, installation plan, how it can be deployed to the customer. What are strengths of a spiral model? Actually, it indicates the insurmountable risk without much cost. That is very important for any software risk identification and mitigation is a challenging challenging thing. But here in this model, it's easy to identify the risk, and that identify the risk at the early stage, and it can be mitigated easily. And users can see the system because of rapid prototyping model. It uses a prototype technology also plus waterfall model. Prototype after doing one complete spiral, after completing, then it will be given to the user for feedback. After that, it keeps modifying. So it uses both prototype model as well as waterfall model. And critical high risk functions are developed first. The design does not have to be perfect. Users can be closely tied to all life cycle models. Early and frequent feedback from the users. Here, things more focus on risk management as well as alternative plan. There won't be any standard plan. It's not necessary what are the document we are designing, what are the model we are designing not to be perfect, because it follows both waterfall model as well as prototype model. In the prototype model, even if the design there's lack of design component, then it will be given to the user, and the user gives a feedback so that it can be modified easily, even if you miss the any design or any algorithmic function. What are the weakness here? Here it takes lot of time for evaluating the risk as well as lowering the risk, and time spent, because it uses both prototype model as well as waterfall. Time spent, prototype model, it takes lot of time actually. It keeps on getting feedback from the user and sending back to the user and correcting, sending back, so time consuming. And model is more complicated because it uses both model, both is a hybrid of this RAD as well as waterfall model. Risk assessment expertise is required. Spiral may continue indefinitely. That is the main drawback in this. Indefinitely, we need to stop the process at one point in time. If you allow the system, it keeps running and it may continue indefinitely. And it's difficult to identify the deliverables as well as milestones in this phase. When to use spiral model? When creation of the prototype is appropriate. Some project prototype is must, because we cannot use the real model for certain with the real time applications, because the consequences will be bad. So in some model we need to develop a prototype. In that case, we can go for spiral. And cost and risk evaluation is, if you give more importance for the cost and as well as risk, then go for spiral model. And it covers up medium to high risk projects, long term project commitment, and because of potential changes in here, when you develop any project, it's a long term commitment, because it reflects the environmental easily. And users are unsure of their needs. If users are not sure about, maybe today their requirement is, tomorrow their requirement changes, then you can go for spiral model. And requirements are complex, time is not important, cost is not important, then we can go for spiral model. Then next model is Agile SDLC. It speed up or bypass one or more life cycle phases. Here also it's like it just merge up the one or more life cycle process. Usually it's the less formal and ready scope. Most of the corporate companies are adapting this kind of they don't want to have the traditional model, because traditional model, it takes time, it's so rigid. And these kinds of models, a modern development life cycle model, it has a flexibility, and it has best features of all the life cycle model, and used for time critical applications. We can go for Agile SDLC, and used in the organization that employ the discipline methods. In the corporate companies, most of the companies they employ this kind of Agile software development life cycle model. This is like project selection, project initiation, working up the project and releasing the project, deploy the release and support the release, sign off the project. That's it. For any team, these are the phases like iteration, warm up, construction, release the end game, production, retirement. These are the now most of the IT companies, they follow up this kind of life cycle model, Agile. Some of the popular models or Agile methods are available. One is adaptive software development, feature driven development, crystal clear, dynamic software development method, rapid application development method, SC Scrum, extreme programming, rational unified process. These are the already we have seen RADM, and this is something variation of this RAD. But most obvious model here is extreme programming as well as rational unified process. This is DSGM. It is applied framework for RAD and for short frame. This is like, it's almost like RAD model, but it uses this rule 80-20. The majority of 80 requirements can be delivered in a relatively short amount of time. That is 80-20 rule. Cycle of this DSGM as usual, it has a feasibility study, business study, function model iteration, design and build iteration, implementation. Feasibility study, all the requirements, planning and all comes under feasibility study. Business study, based on the nature of the company, based on the profit of the based on the like market potential, they prioritize the requirements. And then function model, it involves risk analysis and time box plan. Finally, design and build iteration, implementation. So how it can be adapted here? First, project initialization, determine the intent of the project, why we have to do the project, what is necessary, what is the scope of the project, all these things will be defined in the first phase. Second, determine the project time box, how much you need to, the entire time slot will be divided into time boxes, how many time boxes is required to complete the project. And third one is determine the option number of cycle and time box for each. So for how many times actually the iteration should be done, option number of cycles should also be defined. Write an objective statement for each cycle, assign primary components each cycle, develop the project task list, review the success of the cycle, plan the next cycle. Here inside the time box we need to identify how many cycles should be there and what are the cycles should be repeated, what are the output of the each cycle, project cycle, and what are the, for each cycle what are the project task list, and review the success of the cycle. These are adaptive steps, because here the cycle is not permanent. If you want, you can add one or more 2 cycles. So in extreme programming practices, they more focus on coding. Everything can be communicated in the form of the coding. They have some 12 practices. The number one is actually first before getting into the development, first we need to determine the scope of the next release by combining the business priorities and technical estimates. First, after identifying the business request, project request, then we need to define the scope. Scope not only for current scope, the next scope will also be determined. And after that, what are the scope we have determined, it should be put into the production, then release the new version in a very short cycle. Here here based on that how many releases are there for particular project, you may have 10 releases, 11 releases, each one releases defines each scope of the system. Then all the development is guided by simple story of how the whole system works. Actually it's like continuous process, whereas in the previous life cycle model we are developing each module separately. Instead of each module, here each thing is placed in the separate form, in the form of release. One module can, after developing one module, immediately it can be released, and the whole function can be explained by using metaphor. All the development is guided, simple sad story of how the whole system will work. And simple design, system is designed as simple as possible. Say it should be very simple so that it can be released, and later part it can be merged in the storyboard. And testing, programmers continuously write a unit test and customer write the test for, because it's a continuous process program. Even though the model can be divided into small the entire project can be divided into small module, and that model can be tested, or it can be, after testing it can be released. The programmers keep on writing the unit test code for unit test, and at the same time the customer also tests the features of the model. And refactoring, here another concept is refactoring. Programmers continuously restructure the system without changing its behavior and remove the duplication and simplify. The refinement is going on throughout the project. The programmers keep on, not only if they develop a model with the develop particular paradigm, it doesn't mean it should continue with that. They'll plan alternate direction, then refactoring the things. And pair programming, all the production code is written with the two programmers on one machine. For same problem, two or more than one person can find the solutions. All then they'll work on parallelly. Which one is efficient, that can be taken as collective ownership. So anyone can change the code. It's like all the open source software follow this style, collective ownership. Anyone can debug the code and they can modify, they can post that. Actually, that is called anyone can change any code anywhere in the system at any time. That is collective ownership. Continuous integration, integrate and build the system many times a day, every time the task is completed. Here there is no fixed time, this task will be completed. It is a continuous process. It will be today one task will be completed, the same task will be again refined, and tomorrow also it will be completed. So 40 hours week, work no more than 40 hours week. This kind of programming technique, it allows 40 hours work. And on-site customer, a user is a team and available full time to answer the questions. Here also that's no batch processing kind of thing. The programmer will keep on developing, at the same time customer will also be available at any time throughout the project, and for the suggestions as well as for the answers. And coding standards, programmers write all code in according to the rules emphasizing communication through the code. See, what are the code? There is no separate documents. The programmers can interact through the coding. So the coding standards should be followed. And final model is CMM model, capability maturity model. This is also old traditional model. You just want to know the importance of this model. A benchmark measuring the maturity of organized software process. After developing, this is not a development lifecycle model. After developing, whether the software is developed correct or not, it's kind of a benchmarking model. That is CMM model. It has a 5 maturity levels based on the certain key process area. I'll just go level 5 optimizing. Here optimizing is process change management, technology change management, defect. After completing the software with any one of the software development life cycle, how would you check the, before releasing the beta version or alpha version, how will you check the quality of the software? For that we have this model, CMM levels. There are 5 levels: level 1, level 2, level 3, level 4, level 5. Level 1 initial level, level 2 repeatable, level 3 defined, level 4 managed, and level 5 optimization. 100% is divided into this level. Level 1 initial level, all the requirements analysis will happen at the initial level. Repeatable, software configuration management, software quality assurance, project tracking and oversighting, project planning, requirements management, all this happen in the level 2 repeatable. This takes 15% of time. And level 3 defined, peer reviews, intergroup coordination, software product engineering, integrated software management, training program, organization process definition, etc. And level 4 somewhat higher level, so software quality management, quantitative process management. And level 5 optimization, process change management, technology change management, and defect prevention. This is somewhat like it's advanced level. This not comes under software development lifecycle model. To just ensure how this software lifecycle model it works well with the existing software, or how it can be adapted. All these things can be tested with the capability CMM model. So we say the software development lifecycle model is very important for any software, and maybe there are we have listed only 7 models. Even if we come across many software, they combine more than one model based on the nature of the project, and it can be customized. There's no standard rule that you need to follow this model as it is. It can be customized based on the nature of the project, based on the company background, based on the profit, based on the budget, time, staffing. You can adapt any model, and these are the people who worked in this model. Actually, generally software development there would be steering committee will be there, application system programmers will be there, system analysts will be there, vendors, webmaster, network engineer, other system analyst, database administrator, users. These are the part of the system software development lifecycle model. So let me conclude. what are the things we discussed today. Here the main objective of this session is actually to understand what are the models are available, how one model is different from other model, and what is the necessity of using the models. Mainly to, if you don't use any software development model, it is difficult to ensure the quality of the software and difficult to cover the risk. Risk exposure and quality is important for any software product. So the next class we will see what is software process, how the process can be managed. Okay, thank you.